In this numerical, alternating EMF E equals to 250 sine 100 pi t is applied to a circuit of, first part is of inductance 1 upon, this is pi, 1 upon pi Henry, and other one is, this is 1 upon pi Henry, I should write it down clearly, and the second part would be having a capacitance of 1 microfarad. So we want to find the value of instantaneous current. As we have already did this, that instantaneous current will be given by the expression of what? Of this expression, I equals to I naught sine omega t plus minus pi by 2, depends upon which type of circuit is this. There are few things which are hiddenly inculcated in this topic. We'll see. First of all, they have asked us what is the value of instantaneous current, for which we have an equation. Okay. If I start writing like this, I equals to I naught sine omega t. Before moving on to I naught, I would first of all say that this equation is wrong. Why? Up till this point, this equation was right. Well, what had happened suddenly that this equation is wrong right now? In case of inductance and capacitance, current is not given by this. Current is given by plus minus pi by 2. When is it is plus, when is this minus, depends on whether it is inductive circuit or capacitive circuit. Guys, you have to formulate your own ways to remember this fact. How I have devised it is that I know this, that while we were solving LCR circuit, inductor is always upwards, R is here, and capacitive voltage is here. This thing clearly explains us which voltage is how many degrees or phase angle upfront with any other. For example, when we did AC circuit containing resistance only, we had no or zero phase difference between current and voltage, so resistance is taken here, voltage across resistor. This is the part of LCR circuit, right? When we did voltage across inductor, AC circuit containing inductor, it was, the voltage was 90 degree more than the current, or current was lagging behind the voltage by phase angle of 90 degree. So that is why voltage is drawn 90 degree before this resistance. So by just knowing that voltage in inductor leads the current by pi by 2, I will automatically get the point that current lags behind the voltage by phase angle of pi by 2. So if I am doing the question for this part, for inductance, I would write what? Plus or minus. Voltage is 90 degree leading the current, that means current is 90 degree lagging behind the voltage. And if I am doing the value for this capacitance, I would write equation I naught sine omega t. In case of capacitance, voltage is leading behind the current by phase angle of pi by 2, that makes current lead the voltage by a phase angle of pi by 2. This is actually very simple, only you have to remember this portion. Alright, so I will have to start from this equation. This will give me the value of instantaneous current for both inductance and capacitance. Leave the second part for right now. Okay, so just a second. What should I do about the value I naught? They have not given us current, mean or RMS, nothing. They have just given us voltage. What is voltage? E equals to 250 sine 100 pi t. Now, okay, we want to write this equation in terms of I naught. So I naught is what? I naught is current. According to Ohm's law, current is voltage over resistance. This is a well established fact. Voltage upon resistance. What is the resistance of a circuit while you are dealing with an inductive circuit only? It is called inductive reactance, and inductive reactance is represented by what? XL. What is XL? XL is, the formula for XL is omega L. It is E equals to, XL equal to E upon omega L. Again, the wrong statement. I had to say I naught is equal to E upon XL. I said something else. Anyhow, I naught is equal to E upon omega L. Instead of XL, we have written omega L. What is omega? Omega is the angular frequency, which can be found directly from here, because You know the equation E equals to E naught sine omega t. So this is omega, which is 100 pi. So if I write the value of another thing, I naught is E upon XL or E naught upon XL? Yes, it is E naught upon XL. So E naught upon omega L, E naught is 250. You have to just compare this equation with E is equal to E naught sine omega t. You would understand that omega is 100 and E naught is 250. 100 pi, sorry. So upon omega L, omega 100 pi into L. What is L? The inductor is given, inductance is 1 upon pi Henry. So this is 1 over pi. This goes, so 250 upon 100, that will leave me 2.5 ampere. This is the value of I naught. So my equation would become, instead of rubbing it, I am writing my equation. I will be equal to I naught. I naught is this 2.5 sine, what is omega and t? Omega t remains same, 100 pi t minus pi by 2, because in case of inductive circuits, current lags behind the voltage by phasor angle of pi by 2. Similarly, you can find the value for capacitance. What was the capacitive for this circuit, for this equation? I need to find the value of I naught. Again, I naught will be, in case of capacitive circuit, I will be having it E naught upon resistance offered by capacitive circuit. Capacitive circuit is XC. XC is 1 upon omega C. Okay, XC is 1 over omega C. So omega C gets multiplied here and I am left with E naught was 250. Omega is 100 into pi. Pi is 3.14. C, capacitance is 1 microfarad. 1 microfarad, that is 10 raised to power minus 6 farads. Now what do we get? 100 and 314, they accumulately gives me 314. Now I have 250 into 314 into 10 raised to power minus 6. Minus 6 will give you the exact value of I naught here, and putting the value of I naught in this equation followed by sine omega t plus pi by 2 will give you the exact value of instantaneous current in both the cases. This is just a calculative part which I am not going to solve, obviously. And then what should we be doing about reading in the AC ammeter? What does AC ammeter measure when you are connecting it? Okay, let me make this diagram somewhere. This is my circuit. No, not the resistor part, but the inductive part with an AC ammeter, okay, and our source. What will be this ammeter measuring? I'll give you some options. Number 1, mean or average value of current. Number 2, RMS value of current. And number 3, the instantaneous value of current. For example, if I keep on changing the value of alternating current here supplied, I will also be getting changing values of current here. That means, is it giving me the instantaneous value? I'm just, guys, making you confused. This does not give us instantaneous value. Actually, it gives us the RMS value. Remember this point. The AC ammeter always gives us the RMS value of current, not mean value, not the instantaneous value. Okay. What will DC ammeter give us in this case? DC ammeter will not give us any reading, guys. This is an AC circuit. DC ammeter won't even work in this circuit, right? So remember my point. AC ammeter gives you the RMS value of current. And how will you find out the RMS value of current? Suppose I am doing it for the inductive circuit. So RMS value is IRMS is what? I naught upon root 2. This was the formula. What is I naught? That was 2.5 ampere. So I can solve this because it is an easy, it won't need any calculation part right now. So 2.5 upon root 2, which is what? Root 2 into root 2, 2.5 into 1.414 upon 2. And again, I leave this numerical part into your capable hands. This is how you will be solving such kind of numericals.